Hey YouTube, the scope of this video will be to just introduce you to the concept of a 3D printer and my recommendation of what would be the best budget 3D printer for you and why. If you are a part of a conversation where two people were talking about a 3D printer and you have no clue of what they are talking about, or if you're in the market looking to buy a budget 3D printer and are stumped by the absolute number of options available to you, even if you've got your first 3D printer and you don't understand it, this video is for you. Let's get straight to the point. This is a 2D printer, an inkjet printer to be precise. It prints along the x-axis and along the y-axis. Those are the two dimensions, x and y. The printer carriage moves along the x-axis and the rollers help the paper move along the y-axis, so that a print can be made on any point along the sheet of paper. Say this point is x equals 4 and y equals 6, so this point could be x equals 5 and y equals 3. As you may have realized by now, every point on the sheet of paper can be marked with an x and y coordinate. Now this, on the other hand, is a 3D printer, a FDM or Fused Deposition Modeling 3D printer to be precise. It is a little different from the 2D printer because it allows a third dimension. Along with the x and y, there is a z coordinate to mark every point along the print. What this allows you to do is, marking a coordinate will not be limited to a sheet of paper, but it can be in free space. Here, this point will be x equals 4, y equals 6 and z equals 0 because it's on the surface. And this point would be x equals 4, y equals 6 and z equals 5. Any point on the printing workspace can be marked by their x, y and z coordinates. That's it, it's simple as that. Let's get into some basics of how the printer works. This is a filament, usually made of a type of plastic. The filament is melted and laid over layer by layer by the extruder. The extruder has a hot end that does the melting bit, this bit here. Then it has gears inside that are connected to motors to make sure there is a steady flow of filament when needed. It also makes sure that there is no flow of filament when the flow is not needed. It has a temperature sensor to monitor the temperature of the hot end, and it has these two motors driving the timing belt to help the extruder move along the x-axis. The stepper motors are very precise and can point at any spot on the x-axis with an accuracy of 1/3 of a millimeter. These are cooling fans and they help solidify the molten plastic once they have been extruded onto the printing surface. The entire setup of the extruder, fans and its DC motors are mounted on the Z carriage. This helps the extruder and the entire setup move along the Z-axis. Instead of using bells, here we have screw-type threaded rods connected to the stepper motor to help move the extruder along the Z-axis. Finally, this is the build plate. It has the motors on the inside to help move the build plate along the Y-axis. The printing bed also has the ability to be heated like the extruder setup, as it is important that the print sticks and holds steady to the plate during the duration of the print. There are switches along all three axes to maintain the end limits. For instance, this printer has a printing area of 200 by 200 by 180 in millimeters, which means it can print objects with up to 20 centimeters in length, 20 centimeters in width and 18 centimeters in height. There is a touch screen to operate the printer, a SD card reader so that you can transfer files that you wish to print from your computer. There's also a FireWire to USB if you want to have any direct interface with your computer. I would not recommend using this though, because if your computer crashed or restarted during the duration of the print would fail. And the duration of the print is usually quite high. Use the SD card, it's easier. And here we have the filament spool holder. Printer originally came with the smaller spool holder, this one. But because spools have got larger in the recent past, this 1 kg spool no longer fits on the stock filament holder. So I got this one printed for this purpose, and it works great. There are different types of 3D printers, but it'll take me ages to walk you through each of those types. If you're interested, post a comment and I'll give more details about the other 3D printers. Some of the models I've listed here. This printer, as I mentioned earlier, is an FDM printer and it's based on the design by Joseph Prusa. Let's just concentrate on this model because this is the most popular type. Prusa designed this in a RepRap project and had made it open source. Because it was open source, a whole lot of Chinese manufacturers jumped on board and designed their own version of this printer. Wanhao is one of these Chinese manufacturers, and I think they're cost effective and have excellent customer service. The printer I have supports a lot of materials, but some of them will require a hot end upgrade because the melting point of these materials are higher than the metal that is used to build this nozzle. This will gradually cause the metal to corrode and result in inaccurate prints. The most commonly used filaments are PLA, which stands for polylactic acid, and ABS, which I cannot say, I'll just put it on the screen. And the two most commonly used filament sizes are 1.75mm and 3mm. This model supports 1.75mm. This is the thickness of the filament, or diameter of the filament if you will. Rolls of this sort come in 1 kg packs or in 10 feet packs. They last quite a bit. This roll costed me about £7 on eBay, and I've used it for tons of prints. Though a lot of people recommend ABS prints for the quality and strength of the material, I've been having trouble printing with them. As you can see, they bend after the first few printed layers have become cold, and they tend to pop out of the surface and end up making a whole mess. PLA works fine for me. Got it right the first print, and it's worked fine ever since. The only problem I had was pulling the PLA prints off the print bed. To an extent, I sometimes broke the prints because they were quite hard to get off. But I figured a way around this by spraying some hairspray onto the printing bed. It seems to make it a little easier. The software I use for 3D modeling is 123D. It is free and reasonably easy to use. Once you have the design ready on the 3D modeling software, it will be saved into an STL file. The 3D printer cannot read this STL file, so now you will have to load the STL file into a slicer software. I use Cura. The slicer software can convert the STL file to a .g-code file, which your printer can understand. The G-code contains information on the X, Y and Z axis we spoke about, the extruder and the build plate temperatures, and also the action of the extruder gear motors. In short, it is machine level instructions for the printer to follow. The last topic I wanted to discuss is the base plates and the support structures. Both these options can be accessed in Cura or any other slicing software. Sometimes when prints don't stick to your print surface, it's best you have a base plate setting turned on. This setting will first print a thin flat layer on top of the build plate before the model is printed on it. When there are overhanging objects in your print, remember the printer cannot print on mid-air. Gravity won't let it. Slicing softwares allow the generation of support structures to build overhanging objects. You can later break these support structures away. You can build your own support structures as well, but usually I tend to use the support structures that are provided by Cura. Hope this video was informative. Let me know if you have any questions by posting questions on the comment section below. I'll try to answer it. Take care.